Faraday AI just replicated 94% of scientific research steps completely autonomously, utterly crushing both OpenAI and Anthropic in sheer problem-solving accuracy. While tech giants scramble to defend their massive proprietary models, this quiet open-source breakthrough by DeepMind alumni has changed the game forever. Think about that for a second. An AI system that doesn't just chat, but actually thinks, adapts, and executes entire research papers without a human in the loop. Most people log into a chatbot, type a messy prompt, and wait for a mediocre response. The result is hours wasted editing bad text, correcting mistakes, and manually copying data between tabs. Today, you are going to learn how to break this cycle. This video is your complete blueprint to building a multi-agent system from scratch using no-code integration tools that work for you 24 hours a day. By the end of this tutorial, you will know the exact architecture needed to deploy digital workers that run your business, manage your content, and analyze your competition while you sleep. We are not talking about simple automation or basic email templates. This is about establishing a fully autonomous, self-correcting neural engine for your daily operations. Wait, this is where it gets interesting. While we think AI is safe and highly controlled, a shocking 73% of frontier AI labs have zero public containment protocols for rogue models, despite a massive 300% increase in AI anomalies over the past 2 years. If we do not learn to build structured, self-contained workflows now, we risk losing control of our digital environments completely. Let us address the elephant in the room regarding current safety limits. Independent tests recently bypassed Anthropic's flagship Opus 4.6 safety filters in 3 out of 5 test scenarios, generating restricted material effortlessly. This proves that relying on the safety guardrails of third-party platforms is a massive security risk. You need to build your own local validation layers to ensure absolute control over your outputs. The good news is that we do not need to write thousands of lines of Python code to achieve this. According to a landmark study, companies utilizing structured autonomous AI workflows save up to 78% of manual labor time. Think about what you could accomplish if 4/5 of your daily digital tasks simply vanished into thin air, managed by reliable background processes. Here's what nobody talks about. The shift from simple single-agent setups to multi-agent architectures is happening right now. No-code AI platforms saw an explosive 340% increase in adoption in 2026 alone. Non-technical founders are now building complex software ecosystems that used to require a massive team of engineers, using simple visual drag-and-drop nodes. To build an autonomous system, we must first understand how our digital workers communicate with each other. In a typical workflow, Agent A might find a competitor's article, Agent B will analyze its key metrics, and Agent C will draft a counter-narrative. This division of labor keeps the execution extremely clean and highly efficient, preventing the system from experiencing context overload. But what happens when one of these agents makes a mistake or halts the process due to bad data? Researchers at MIT built a self-updating database AI that successfully reduced operational errors by 89% compared to systems managed by humans. The secret lay in building a recursive error correction loop that forces the AI to check its own output before saving. I didn't expect this either, but this simple double-check mechanism is incredibly easy to implement inside no-code builders. By routing the final text back through a validation agent with a specific set of rules, you eliminate almost all hallucinations. This validation layer serves as the quality control inspector of your digital factory, ensuring high standards are always maintained. Let us take a look at customer support. A Stanford case study showed that routing incoming user queries through a specialized multi-agent system reduced average customer response times by 92%. Instead of waiting 30 minutes for a real person, customers received highly personalized, accurate solutions in under 2.5 minutes, keeping customer satisfaction scores extremely high. We start our build by setting up the central database. This database acts as the single source of truth for all of our automated agents. Every competitor report, every social media comment, and every piece of market data will flow into this central hub, allowing your agents to access up-to-date context whenever they trigger a task. Nobody told you this, but setting up your database structure correctly is actually 80% of the battle. If your database columns are messy or poorly labeled, your autonomous agents will quickly get confused and feed wrong variables into their prompt inputs. We must structure our tables with clear data types, unique identifiers, and predictable relationship keys. Now, we establish our first trigger node. In the world of no-code automation, the trigger is the event that wakes up your digital workers. This could be a new competitor publishing an article, a specific mention of your brand on social media, or a simple time-based interval that runs every day at 8 in the morning. Once the trigger is activated, our primary gathering agent jumps into action. This agent is specifically programmed to use search engines, scrapers, or social media feeds to fetch the raw data we need. Instead of manually scrolling through websites, our gatherer collects and packages everything into clean JSON format within seconds for the next step. And then something shifted in our workflow. We realized that passing raw data straight to a standard language model often leads to bad outputs because the text contains too much irrelevant noise. To solve this, we insert a specialized preprocessing node that strips out raw HTML, advertisements, and repetitive footers before passing the core message along. This leads us to our competitor research engine. By monitoring changes in competitor pricing, feature announcements, and search engine optimization keywords, this agent can generate an automated report every Friday afternoon. Your marketing team can sit down to a prepackaged competitive brief without a single human lifting a finger to research it. Think about that for a second. While you are working on high-level strategy, your automated system is continuously watching the horizon. It notices a price drop on a key competitor website, flags it instantly, analyzes the historical trends of that product category, and drafts a tailored promotional email to counter their move. Let us talk about how we can write the precise system instructions that guide these agents. Most users write prompts like, "Write a social media post about this." This is far too vague for an autonomous digital worker. We must define their role, set strict boundaries, specify the input format, and dictate the exact output format. A highly robust system prompt includes constraints like, you must never output conversational filler, you must output only valid JSON, and you must flag any missing data fields. By enforcing these rules, we ensure our agents act like predictable software modules rather than highly erratic, unpredictable chatbot instances. Here is what nobody talks about. The absolute magic of multi-agent collaboration lies in role conflict. By setting one agent as the creator and another as the critical editor, you create a natural competitive tension. The creator agent tries to write engaging content, while the editor agent flags cliches, factual errors, and bad formatting. This creative tension prevents the quality of your automated content from degrading over time. If the editor rejects the content, the workflow loops back to the creator with a detailed list of edits. This loop repeats up to 3 times until the editor signs off on the quality of the post. Now let us design our content distribution node. Once our dual agent system signs off on a draft, the distribution engine automatically reformats the core message for different platforms. It creates a short, punchy thread for social media, a highly professional update for LinkedIn, and a long-form article for your corporate blog. Wait, this is where it gets interesting. The system doesn't just post these updates at random. It references a specialized database containing your historical engagement metrics, determines the peak traffic window for each specific channel, and automatically schedules the publications to maximize your brand reach. This brings us to our self-updating database logic. Whenever a post is published, an analytics tracker node wakes up 24 hours later to pull the performance data. It records impressions, likes, and click-through rates directly back into our master database, creating a feedback loop that the generator agent uses to optimize future drafts. Think about that for a second. You are building a system that literally learns from its own historical successes and failures. The generator analyzes which headlines generated the highest engagement over the last 30 days and begins adjusting its writing style autonomously to replicate those winning patterns. I didn't expect this either, but many businesses overlook the power of customer routing systems. When a customer reaches out, a routing agent analyzes their sentiment, extracts their intent, and categorizes the message. High-priority billing issues are instantly sent to your human team, while routine questions are resolved by your AI agents in seconds. Let us build a routing system step by step. First, create an input webhook node that listens for new messages from your contact form. Next, connect this webhook to a classification agent. This classification node is provided a strict set of rules to determine whether the incoming request requires urgent human intervention. If the message is flagged as low risk, the system fetches the relevant support documentation from your database, drafts a highly accurate response, and emails it back to the customer. This completely removes the manual support queue, leaving your human agents to focus exclusively on complex, high-value user problems. Nobody told you this, but you can also use this exact same framework to handle incoming sales leads. When a lead downloads a resources guide on your site, an agent can check their company domain against public data sources, estimate their budget size, and draft a personalized outreach email for your sales representative. By enriching your leads automatically, you ensure that your human sales team never wastes time chasing bad contact information or unqualified prospects. Us in taxonomy and time some of the neighbor sticktioning dangers and regedata problemide as a sediment minerging, with his lighter taxomabiation to his ppx as a data body as a creatures, with all day of customized problem, everything their frame datas one docs and sided teachers. Or interesting health of the wrong course, one problem by problem follows, one having this consummated vage every time. How it is costumated complaint. Running traditional teams of human researchers, writers, and support agents can cost thousands of dollars every single month. Now, by shifting these tasks to an autonomous no-code system, your operational costs drop to just pennies per run, allowing your business to scale profit margins rapidly. And then something shifted in how we calculate return on investment. The value isn't just in the money you save on labor, it is the massive velocity your business gains. While your competitors are sleeping, your systems are running experiments, updating leads, publishing content, and resolving support issues in real time. To achieve this high-speed execution, your architecture must be highly modular. Do not try to build one giant, massive agent that does everything. If that single node fails, your entire automated business comes to a grinding halt. Instead, build small, independent tasks that hand off clean data to each other. By keeping your nodes modular, troubleshooting becomes incredibly simple. If your content starts looking weird, you know the issue lies specifically within the drafting node, not the scraping node or the database node. You can easily jump into your visual builder, tweak the offending prompt, and resume the entire system safely. We are entering an era where you shouldn't just use artificial intelligence to write your emails. You must let autonomous agents run your entire process. This fundamental paradigm shift is what separates traditional creators from the next generation of highly automated, hyper-profitable digital enterprises that scale indefinitely. Wait, this is where it gets interesting. Once your agents are running smoothly, you can begin layer building advanced decision trees. Instead of simple linear paths, you can build conditional logic pathways that execute completely different subroutines based on sophisticated variable evaluations inside your database fields. For instance, if your tracking agent discovers a massive spike in customer complaints about a specific software bug, it doesn't just email your team. It initiates an emergency workflow, drafts a public status page update, flags the critical issue in your project management dashboard, and alerts your lead engineer via text message. This level of automation creates an incredibly resilient business model. Your organization becomes capable of reacting to critical marketplace crises within minutes instead of hours, saving thousands of dollars in potential lost revenue and protecting your hard-earned brand reputation. Here is what nobody talks about. You can easily integrate these visual agent workflows with your favorite everyday productivity applications. You can connect them to team chat rooms, calendar interfaces, spreadsheet trackers, and email servers, allowing your automated agents to communicate with you exactly where you already work. This means you do not need to constantly monitor a complicated, clunky back-end software dashboard to keep an eye on your digital team. Your agents will send you short, highly formatted daily summaries directly to your favorite messaging application, keeping you informed on their progress in real time. Let us talk about the long-term future of these multi-agent ecosystems. Industry forecasters predict that 68% of enterprises will actively deploy multi-agent systems by 2027. This is no longer a fringe hobbyist technology. It is rapidly becoming the standard operational framework for modern business systems. If you do not master these systems now, you risk being left behind by competitors who can produce 10 times more content, qualify 20 times more leads, and handle support requests instantly. A course point and monarchical work act, and fightus for maybe a data body as toko bis situation close. The barrier to entry has never been lossers. The barrier to entry has never been lower. Work it. Its tentry has never been Mation either. Didn't expect this either. But building these workflows actually teaches you to think more logically about your own manual business operations. When you are forced to break down a task into microscopic, step-by-step instructions for an agent, you quickly identify inefficiencies and redundant steps you have been doing for years. You will start to realize how much of your daily workday is actually spent on low-level task switching, like copying names from a spreadsheet to an email window. These micro-tasks are highly exhausting to your creative energy, and they are precisely the things that our digital systems are designed to master. Let us outline how to build our competitor tracking module. We start by gathering a list of our top 10 competitor websites. We feed these web URLs into a scraping scheduling service that checks for updates twice a day, monitoring for changes to headers, pricing blocks, and landing pages. Nobody told you this, but scraping can sometimes trigger web blocking protocols if not handled carefully. To prevent this, we configure our scraper nodes to utilize rotating proxy servers, simulating natural human browsing behavior. This ensures our data gathering processes remain highly reliable and completely uninterrupted over long periods. Once we have the raw HTML page, we pass it directly to our extraction agent. This agent is instructed to find any newly added text sections and outline them clearly. On Faraday, it outputs a neat list containing the old page text, the new page text, and a short summary of the changes. This summary is then passed along to our marketing positioning agent. This agent assesses whether the competitor's change poses a threat to our current marketing angle. If it does, the agent automatically drafts a series of recommended modifications to our own landing page headlines to stay ahead, and then something shifted. We realized we could also automate the deployment of those landing page updates. By connecting our positioning agent to our website host API, we can program the system to safely update draft pages for our team to review with one click, cutting project time down significantly. Think about that for a second. This entire cycle of competitor analysis, copywriting, positioning adjustment, and landing page draft updates occurs in less than 5 minutes. A project that historically required multiple marketing meetings and days of work is now completed before your team even pours their first morning coffee. Let us talk about setting up system memory. Standard language models treat every request as an isolated event, with zero recollection of previous conversations. To make our digital workers truly smart, we must connect them to a vector memory database that stores previous outputs and user interactions. By storing historical events in a vector database, our agents can perform semantic searches before executing any task. On writing a new email, the agent retrieves the style of successful previous emails, ensuring its tone is perfectly consistent with your established brand voice across every touchpoint. Here is what nobody talks about. This memory layer is also critical for error prevention. When an agent tries to run a process that previously failed, it can quickly query its error logs, identify the historical point of failure, and proactively adjust its execution steps to avoid making the same mistake twice. This advanced self-healing behavior is what elevates simple automated scripts into truly intelligent digital workers. The system continuously adapts to its software environment, handling API changes, bad data formats, and transient server errors without requiring constant manual maintenance or technical oversight. Wait, this is where it gets interesting. You can start deploying these digital workers for less than $20 a month in running fees. This makes it incredibly easy to experiment with different business models, scale marketing workflows, and automate tedious customer administration tasks without any financial risk. By eliminating financial and technical barriers, you can focus purely on strategic execution. Your primary task shifts from performing repetitive work to directing a highly efficient digital workforce, giving you the freedom to scale your business to levels that were previously unimaginable for a single individual. The entire digital landscape is shifting right before our eyes. The question is not whether this technology will redefine business operations.